Okay, so now that our app is deployed with CloudFormation, you might have noticed that we have these kind of long, randomly generated looking names. And instead of using the nice name like songs for a song table, we have this kind of long thing. And this is what happens when CloudFormation manages your resource creation. It has its own naming scheme, which is the stack name, the resource name, and then a random ID. And it can take a little getting used to having these random IDs, but it's actually pretty nice if you can live with it because you can create multiple instances of the same stack and not worry about them conflicting and, have multiple dev and prod instances instead of just having, one dev, one prod. Um, but if we try and run our app, we're going to see that, we get an error. Basically, we're trying to look at the songs table, but we have this big long name here. So what do we do? Well, you're probably thinking, hey, I saw this before with environment variables. And that's something we can use here pretty easily with our Lambda config. So we'll go back to our template and we just add a section called environment, subsection called variables, and then a map of whatever you want. So we'll say song table. And since we have the dynamo table right here, we can just reference this. And now when CloudFormation creates our function, it'll grab the table name and put it in this environment variable. So that's great. But now the tricky part, how do we update the code? And you're probably saying, hey, why is that tricky? I've done this a million times in Java before. You just say system.getEnv and then pass it the name of your variable, right? But this is not going to work because in Java, annotation attributes have to be constant expressions. And so even if you extract this to a string somewhere, it's not going to work. It needs to be a constant expression. So we'll go back to song. So what we want to be able to do is say something maybe like, well, pull this from the environment. Luckily, there is a mechanism to do that with Dynamo. We can create a table name resolver. And you can see this interface lets you dynamically generate what name you should use based on the class and the config. And if we look at the class hierarchy, we can see there's a default implementation. So what I'm thinking is let's create our own instance of this. We'll call it environment table name resolver, and let's extend the default table name resolver. Okay, let's steal this code. And so now we need to think about what are we going to do. So we are talking before about maybe using the table name here as the environment variable name, but then we need to think about, do we always want to do that, or do we sometimes want to support, just standard static names? And so something I'm thinking is, a lot of times you see the $sign as a convention that something should be taken from the environment. So let's do that. So here we'll check to see, let's get the name from our parent class. And then we'll see if name that starts with a $sign. Let's return system.getEnv. And then we need to strip the $sign, so everything after the first character. And then otherwise, let's just return what the name would have been. Great. So now we just need to tell the mapper to use that. So we'll create an instance of DynamoDB mapper config. And this is DynamoDB mapper config builder with table name resolver, new environment, table name resolver, and build that. And then we'll just pass it here. Okay, great. So let's compile and deploy those changes. So what we've done is create our own resolver that looks in the environment if the table name starts with a $sign, otherwise uses the default name. And we're passing that to our mapper. You can also pass in the config on a per query basis if you have per query configuration. And there's also some built-in things for doing just simple name overrides. There's something called table name override that lets you basically just give it a name to do replacement. And that works great, but it's not as reusable if you're using multiple tables with your mapper, or if you just want to use it everywhere. So I think the approach we took is a good one. So let's go back here and reload this config, and we should see here's an environment variable we set from CloudFormation, gets populated, which is great. Let's run it. It takes a couple seconds the first time you run a Lambda function, but we should see our list of songs come back, and let's see. There we go. Great. So in this video, we saw how to dynamically pass information about our CloudFormation environment using environment variables and how to dynamically resolve the table name to use in the Dynamo DB mapper. Thanks for watching.